that we have got a compound angle. Do you all see that? Huh?
Yes.
It's a compound angle for what? For sine or cos? It's a compound angle for cos. Right. So you can make this 4 theta your alpha, and that 40 degrees your beta. And be careful of that plus. Okay? Remember, for cos, if there's a plus between the expressions after the expansion, then in the original one, before expansion, you must have a minus between the angles. So this becomes cos 4 theta minus 40 degrees is equal to -1. Alright? Then this trig equation here is a grade 10 trig equation. Remember when you first introduced trig equations in grade 10? That's a grade 10 trig equation. So to solve this, don't touch the 4 theta minus 40 degrees. Take this cos to the right. It becomes shift cosine of -1. Because the ratio is -1. Okay? But because cosine has got two general solutions, you have to put plus or minus there in front. Okay? So like plus or minus shift cos of -1 plus k times 360, where k is an element of integers. Alright? Then you need to be aware that your reference angle, because I understand that some of you go for tuition and you also ask other people. This shift cosine of -1, when you put it in the calculator, gives you 180 degrees. This 180 degrees is called the reference angle. The angle you get after putting the ratio in the calculator, that is putting shift cos, shift sine, shift tan, is called the reference angle. There is no mark for it for writing that it's called the reference angle. There is no mark for that. It's just that the teachers, when they teach, they just write that the reference angle is called. There is no mark for that. In my case, when I teach, I don't need to write that reference angle is this. Because I know that the value that the angle that I get from the calculator, that's my reference angle. Okay? So when we get here, you need to be aware the reference angle is 180 degrees. That's the angle you get from using a calculator. Okay? Then from here now, you need to split this equation into two, the positive 80 and the negative 80 separately, so that you can be able to solve for theta. Be aware that there are two equations here because of this plus or minus. Okay, so I'm going to split it up into two on the next page. You following that? So on the next page, I started with positive 180 degrees. That's one there. I started with the positive 180 degrees. So if I start with positive 180, take the minus 40 to the right, I'll get 220. Right? Plus k times 360, where k is an element of z. Always don't forget to write this. Right? Because sometimes it is allocated a mark. Just for writing k is an element of integers. Yes. That's the hedgehog. That's the hedgehog. Okay, there is no rule which says you must write it at the beginning and then at the end. If you want to write it throughout, that's okay. If you want to write it once, as long as you write it, right? As long as it can be seen, okay? Yeah. No one should tell you that the rule says you must write it at the beginning, then at the end. There's nothing like that. Okay? Alright. Then, from there, we solve. Okay? We divide both sides by 4. Now, you need to be aware that this is a term on its own. That's also a term on its own. So you divide the two terms on the right by 4 until you get your answer. Okay? This equation here is called a general solution because it can be used to determine all the values of theta that can satisfy that trig equation. Okay? If you were to find values of theta, then you have to substitute k as an integer. Starting with k equal to 0, and then you oscillate k equal to 1, minus 1, positive 2, minus 2, and so on. Okay? And there is no way out. The general solution will always be there in examination. They will bring one question on the general solution. So you have to know again, usually it's 5 marks of trig. Usually 5 marks. Maybe it can be 6 or at least 4, but generally it's about 5 marks. Okay, and your trig contributes about 40 marks to the 50 marks now. So your maths paper 2. So about 10% of trig is going to be the solution question. Alright. Alright. So then, after considering the positive, you consider the negative. Well, there are 2. So I need to get 2 general solutions. Then I'll take my minus 40 to the right, I'll get positive 140 degrees plus k times 360, where k is an element of z. Then I'll simplify, get theta equal to minus 35 degrees plus k times 90. And of course, k is an integer. And then you're done. Okay. Is there anyone who has got a question?
No. No. You can go back one.
Wonder how we learn here to variety anything down.
But when you send it data, you see that step there, the third one, where it says, when you go shift calls.
Yeah.
Can you write it above there, like, just do a separate, like, step there with your answer and not include that step, and include the answer in that step that you want. But you have to say call shift like that.
Okay.
So now?
Are you talking about writing separately without writing the general solution itself, the formula?
Yeah.
Well, you can do that, but in the end, you are going to have to put that reference in order.
Yeah.
It's okay.
I know nothing is
Yeah. See, it's a quadratic. C is quadratic. In actual fact, for C, you don't need the rate of double angles and compound angles. C is quadratic. All right, let's get on. Okay, then I chose G. Listen, I don't know. Listen, I want you to be aware that by the time you write, say, the June exam or the trial examination, final examination, I need to have covered this. That when if you see it, you won't say, but the teacher didn't teach us this month.
No.
Okay. At least you have some kind of familiarity with it. But you said God that taught us. All right. So we have got that. Now this trig equation. Can you stop what you are doing and pay attention?
Stop.
Like we have got sine squared theta. That's minus sine 2 theta, and that's cos squared theta equal to 0. But this question here, you can be tempted, okay, to add the sine squared and the cos squared theta. I would not advise that, okay, for this question here. I would not advise that because you might end up having, when you simplify that sine 2 theta after getting 1 there, you might end up having some issues with the resulting equation. So my suggestion, obviously when you're doing the question, you also have to think. I don't want to take the ability of you to think, because maths is a thinking subject as well. Right? So you have to think about what you are doing, whether it makes sense or not. So the best way would be convert the minus sine 2 theta to minus 2 sine theta cos theta. Once you do that, you create this trinomial. What is the name called? Sorry, what's the name of that trinomial? I told you before. Those of you who listen, those of you who listen when I'm talking, I rephrase you. It's a if you relate it to your grade 9 and grade 10, okay, it's a special trinomial. And it has got a sister or a brother. There are two. What is it called? Have you ever right? X squared minus 2xy plus y squared. If you factorize that, you get x minus y all squared. Also, x squared plus 2xy plus y squared. If you factorize this, you get x plus y all squared. What is the name given to a trinomial that can be factorized and you get two identical binomial factors? Perfect square what? Trinomial. Thank you. It's called a perfect square trinomial. So, this sine squared theta, treat it like the x squared. The 2 sine theta, treat it like the 2xy. The cos squared theta, treat it like the y squared. Follow what I'm saying? Yeah. You are relating your algebra and your tree. And I have to tell you this if you've never heard this. Algebra is the foundation of tree. If you don't know algebra, the chances are very high that you have issues with tree. And that's the scenario why most learners have a problem with tree, because the algebra is not very strong. If the algebra is strong, well, that's the foundation. You find tree very useful. Okay, so if you factorize it here, you get sine theta minus cos theta all squared equal to 0. Then you take square roots, both sides. Once you do that, by now you should know from your knowledge of exponents and said that the square root of sine theta minus cos theta all squared is going to be equal to sine theta minus cos theta. Okay, I don't have to remind anyone about that. That's equal to 0. Then you take the minus cos theta to the right, you get a positive cos theta. The moment you see sine theta on one side, cos theta on one side, it means you have to create tan. To create the tan, you divide both sides by cos theta, then you get tan theta equal to 1. Okay? So, the double angle fundamental identity from grade what? 11. Together with your knowledge of trig equations from grade 11 as well. What's your question? Yeah. What I did was I took the minus cos theta to the right. Okay? Then I realized that I cannot solve this equation. Sine theta equal to cos theta. You can't solve it as it is. You understand? So what do? Create what? Tan. Divide both sides by cos theta, not by sine theta. Divide both sides by cos theta. And then you get the tan on the left, then you have 1 on the right. So you end up having the equation tan theta equal to 1. Okay? Once you get here, it's grade 10. You should start smiling. Okay? And then your blood must be flowing nicely. Then the general solution for tan is only 1. So you end up having theta equal to shift tan of 1 plus k times 180. Be very careful with the general solution for tan. Some learners they put k times 360 there. It happens. And it's a very common mistake. Right? Then shift tan of 1 is a 45 degrees. So your final answer will be that. Okay?
Yeah, you can't.
Any question? Any question?
So if the also sign of any
Sorry?
with any like
All right. So that's where I stop. Let me ask you to do a question yourself.